Okay, we are on session 4 of lesson 5, beginning on page 103 in your textbook. Lesson 5, session 4, page 103, and we're going to go through 106. Remember, you've already attempted these problems on your own, and now we're just going to go over them together. So this is just more of the going over part. You've already attempted these. So the example, write an expression that is equal to 36 using each number and symbol below exactly one time in the expression. So we're trying to get to 36. So we're going to use the numbers 5, 8, and 8. This is a power of 2, a division, an addition, and parentheses. Look at how you could use reasoning and the order of operations to make an expression whose value is 36. I know that 6 times 6 is 36. And that 6 squared is 36. That means I can use 5, 8, 8, the division sign, and a plus sign to write an expression with a value of 6. Then I could put parentheses around the expression and square it to make it 36. So I know that 8 divided by 8 is 1, and 5 plus 1 is 6. So we're trying to figure out inside the parentheses something that we can square, which would be 6, to get 36. Well, I know that 8 divided by 8 is 1. Add 5 gets me to 6. What is 6 times 6? 36. Okay, number 1, what is the value of the expression 1/10 to the third power? Show your work. So we are doing 0.1, 1/10 times 1/10 times 1/10. Okay, I actually think in this situation that trying to maybe multiply with decimals is more challenging than changing it to fractions. So if I use this as a fraction, 1/10 is just 1 over 10. 1 times 1 times 1 is 1. 10 times 10 times 10 is 1 with 3 zeros. So that's 1 over 1,000. Looking at this then, 1 in the thousandths place. So 1 in the 1,000ths place would get me the answer of 1,000th. Okay, if you did multiply it, you'd have 1 times 1 times 1, and you would get 1, and then you would have to move that decimal place back to add in your two zeros, and it would give you the same answer. So answer 1,000th or 1 over 1,000, same thing. Different ways to represent it. Okay, question 2. An architect is trying different dimensions for the room shown below. Write an algebraic expression that architect can use to find the area of the room. Then find the area when x is 6. So when we're looking at this problem here, we got different steps. We have to use the whole thing. So think back a couple of lessons ago when we were talking about splitting parallelograms up to find the area. We know the area over here for this little guy is going to be 3 times 4. We're going to add it to the area of the larger square, which is x times x. So the algebraic expression, this is what it would look like. You could also simplify it to be this. You could also even go, since we're simplifying it even more, to look like that. Well, now they're telling us that x is 6. So 12 plus 6 squared. 6 squared is 36. I'm going to add 12 to that for an answer of 48 meters squared. So that one should be 48 meters squared. Number 3, what is the value of 2 plus b times the quantity a squared plus 4 when a equals 2 and b equals 4? This is a substitution problem. So we're going to go 2 plus 4 times the quantity being the parentheses, plus 4. That looks like that. Exponents happen first. So 2, this isn't going to change. 2 squared is 2 times 2, which is 4, plus 4. Now we're going to do the 8. 4 times 8 is 32, and I have a 2 to go with it. That's going to give me 34, makes my answer B. Zara chose D as the correct answer. How might she have gotten that answer? So we're looking at how do you get 48? Well, we know that something times, 24 times 2 is 48. So we could look here, maybe the 2 plus the 4. Oh, maybe she added that first. And that would have given her a 6. So she added here, which gave her 6. So 2 plus 4 is 6. And then she has this left inside. 2 times 2 is 4. 4 plus 4 is 8. And then she was left with 6 times 8, which is 48. She did not follow order of operations. She added here instead of going on the inside of the parentheses first. Okay, question number 4. This one's got quite a bit of work that has to come with it. So I'm going to try to move it here so we have some room. Okay, which expressions have a value of 100 when m is 5? Select all that apply. So we're going to substitute in. Actually, I'll move it this way for you. Okay, we're going to substitute the values in and see what we get, and if we get 100. If we get 100, we're doing something right, and we'll circle that one. So m is 5. So this one's going to be 2 times 5 squared plus 50. 5 squared is 25. 2 times 25 is 50. 50 plus 50 equals 100. A is correct. B, inside the parentheses, you're going to have 2 times 5 squared plus 50. 2 times 5 is 10, so you're going to have 10 squared plus 50. 10 squared is 100. 100 plus 50 is not 100. C, we're going to put in 5 plus 5, and we're going to square it. 5 plus 5 is 10. 10 squared is 100. It works. D, we're going to substitute in. This is going to be 5 to the third divided by 5 times 4. 5 times 5 times 5 is 125. Okay, 125 divided by 5 times 4. 125 divided by 5 is 25. 25 times 4 is 100. D does work. Okay, for E, we're going to have 4 times 5 squared. 5 squared is 25. 4 times 25 gives me 100. The last one, in the parenthesis, 4 times 5 squared. 20 squared, 20 times 20 is not 100. So I know I can give it as not correct. Okay, question number 5. Write 3/8 as a power with a base of 9. So right now my base is 3, my power is 8. I want you to try this one if you haven't done it yet, but I'm not so worried about understanding it as much or seeing a repeat of this problem. But to try this, so I'm going to write out my 8 threes. 5, 6, 7, 8. So we're trying to get a base of 9 is our goal. So we're trying to get to 9. So here's a 9, here's a 9, here's a 9, here's a 9. So 9, 9, 9, and 9. Still multiplying. How many 9s do I have? I have 4. So 9 to the 4th is the same thing as 3 to the 8th. Number 6. What is the value of the expression x cubed, or x to the third power, minus 1,750 when x is 30? Show your work. So even if you use a calculator to support you here, you still need to show your work to help you out. So x to the third minus 1,750. This is really going to be 30 to the third minus 1,750. So our problem here is going to be 30 times 30 times 30. Okay, if we do 3 times 3, we get 9. 9 times 3 is 27. We have to add in 3 zeros for our multiplication. So we're taking 27,000 minus 1,750. And when we do that, we get 25,250. Remember, because it is a video, you can pause and go back and do whatever you need to fix your work. Number 7, double brackets, double parentheses. Remember, brackets are just an extension of a parenthesis, so don't stress when you see those. Treat them as though they are parentheses. Okay, so we're going to solve this, and I'm going to rewrite it. I'm going to show you what I mean by that, not worrying about the parentheses or the brackets looking different. Okay, first thing we do in PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. First thing we do is parentheses. Here, 3 squared, is 9. 9 minus 7. We're still going to have that 4 here. Okay, another set of exponents. 4 times 4 is 16. And I'm rewriting in each step. It helps me stay focused. Inside the parentheses, I got a 2. Here's 8, so 3 times 8 minus my 16, give me 24 minus 16, which gives me the final answer of 8. So my solution for this problem is the number 8. Okay, last couple problems here. 8. There are 32 teams in the first round of a basketball tournament. 1/2 of the teams that play in each round of the tournament move on to play in the next round. Explain why the expression 32 times 1/2 to the third power represents the number of teams that play in the fourth round. So we're not solving anything here, we're talking about it. So round 1, you have 32 teams, right? So we're going to take half of that to go to round 2, half of that to go to round 3, half of that to go to round 4. So how many times did we take half? 1, 2, 3. So it represents it because there are 3 rounds to get to the fourth. So to go from the first round to the fourth round, there are 3 rounds. Equals the power of 3. How many teams play in the fourth round? We kind of already solved that. We know the answer is 4 teams, but you could also solve it by doing 1/2 times 1/2 times 1/2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So you would take your 32 teams, multiply it by your new fraction you made, which is 32 over 8, which simplifies to 4, which we already knew the answer was 4 teams. Okay, the value of 2 to the power of 14 is how many times as great as 2 to the power of 11? It's a little tricky, but I'm going to solve this for you and then show you how this works a little bit different. So 2 to the 14th is 16,384. 2 to the 11th is 2,048. If I divide these two numbers, I'm going to get my answer of 8 times. But what I want you to understand is going 14 to the power of 14 to the 2 to the power of the 11th is 2 to the power of 3 different. Okay, what is 14 minus 11? That is 3. Your base is still 2, so it's 2 to the power of 3, which is 2 times 2 times 2, which gives me my 8. Okay, so yes, you go down 3 powers, but your base is still 2. Question 10, write an expression that is equal to 8 using number and symbols below exactly 1 time in the expression. Explain your thinking. So we got to get this to equal to 8. And if you're taking the time to watch this video, I actually want you to write this answer, send it in an email to me, what you think it could be. And maybe there'll be some extra credit or an extra point of some sort if you get to this point and you get it correct. So go through, check the rest of your answers, try number 10 and send it to me in an email or put it on a piece of paper so when I get back, I can check it.